Hi everyone, welcome to MAT5890 online lecture. Online lecture consists of two parts, the videos and basic quizzes. So after seeing each video, I recommend you to go to Canvas to solve basic questions to check your understanding. So quizzes are due on March 25th at 11:59 p.m. for today's portion. Okay, so we discuss a quick review of the chapter 7 to 9 today because you have to submit final project plan soon, and I want to give you some overview of more advanced statistical modeling methods. So chapter 7 to 9 covers statistical modeling for supervised learning. So this is for basically regression and classification problems. Okay, so think about the most basic model to relate variables x and y. That is the linear model. So y is equal to beta naught plus beta 1 x plus epsilon. And there are a number of ways to deal with nonlinear relationship beyond this. So the first example is polynomial regression. So as we have already discussed, a simple way to extend the linear relationship is the polynomial regression. So in addition to first two terms, you can add quadratic term, cubic term, up to the term of x to the this power. So you can see that even though this is not a straight line, still it is called linear regression because this model is linear with respect to parameters, and parameters are estimated by least square methods. So this is just a special case of multiple linear regression. So estimation is as simple as linear model. Higher order terms can be also included in the logistic regression. So remember that in logistic regression, we model probability of y is equal to 1. Here, y is binary response variable, so either 0 or 1. In usual logistic regression model, we express this probability of y is equal to 1 as some function of beta naught plus beta 1x. But also that we can put some additional terms. In logistic regression. In logistic regression, since this is already probability, we don't have any error term here. So this is illustrative example of logistic regression. So the problem is to regress wage of people by age. And while the relationship between these two variables are not entirely clear, at least you can find some cluster here. So it indicates that some people between age 35 to 60 have higher salary than other people. So if you fit wage on age, probably the salary is higher for in the middle of the range, and salary is lower for younger people and older people. So in this case, if you fit the linear regression, probably the result is very flat straight line. But if you fit the cubic curve or even the fourth degree polynomial, we can have better fitted line. So this is linear regression for polynomial regression for usual case. And right hand side is logistic version. So think about the probability that wage is larger than 250. That is basically to identify probability that people are above this range. If we use usual linear logistic regression, the fitted curve should be very simple logistic curve. but it actually misses the truth. But if you include quadratic, cubic, and the fourth power of h, then we can actually fit more reasonable probability. So in either case, the polynomial regression works better than just linear regression with linear term. Okay, so now you go to the canvas and you can solve the question 3.24.1, the first part. See you then.